Welcome to the Transportation Infrastructure Perception Data Fusion and Detection using AI Technology Senior Design Project. We will start off with our poster design, which you can see right here. And starting off, we have our scope and requirements. This project's objective is to utilize a variety of sensors. Those include the LiDAR, radar, 360 camera, stereo depth camera, and thermal cameras. These are used for the tracking of vehicles and pedestrians, and the data will be cleansed through algorithms to be used for traffic intersections and safety monitoring.
For ConOps, the end users will be the US DOT and the National Highway Safety Administration. The design must be capable of detecting and distinguishing objects passing through the intersection at UNC Charlotte Parking Deck CRI Level 4. The design provides the end users with the ability to further understand and research traffic through AI and machine learning technologies.
Here is a project design flow diagram that outlines the intended process from collection to final output. Here are the sensors in a short description of their output from left to right. The Quantigy LiDAR for point clouds, the R-Gauge radar for object and speed detection, 2 different FLIR thermal cameras for thermal data detection, the Views XR 360 camera for 360 views, and finally the Mintai stereo depth camera for capturing depth information. The raw data from these sensors will go through several unique processes for cleansing this data, including machine learning algorithms and models like YOLO one-shot detection.
Once the data has been loaded into the database, we can combine the data sensor and use them to cross-check each other's object detections, verify things such as speeds and trajectories. Later, that data will be fed into a data fusion algorithm that we can use to make decisions about traffic regulations and other applications.
The data was collected in the CRI tech. The setup was as follows. The main purpose of the collection was to count the number of objects passing through them and get its position and velocity. The output is shown in the right.
The next stage of the project is to build the AI models for each of the team sensors. We will use sample recordings in our database to train and classify the models with vehicles and pedestrians. Next, we'll compare the accuracy of each model and integrate the feedback from each one to achieve higher accuracy. And then we're going to create an on-the-go recording system for each sensor combined together.
Thank you for watching our presentation. Our contact information is shown as you see. Thank you.